Today's daily LeetCode problem of the day is minimum number of operations to move all balls to each box, number 1769. For this problem, we have an n amount of boxes, and we're given a binary string called boxes of length n, where boxes of I is the character 0 if the ith box is empty, and the character 1 if it contains one ball. So in one operation, we can move one ball from a box to an adjacent box. If the box of index I is adjacent to the box of index j, it would be the absolute value of I minus j would equal 1, meaning they're next to each other. We want to note that after doing this, there may be more than one ball in some boxes. So we want to return an array called answer of size n, where the answer of I is the minimum number of operations needed to move all the balls to the ith box. So each answer of I is calculated considering the initial state of the boxes. So let's go ahead and jump into the intuition of this problem. So this problem is a classic problem of calculating the cost of moving elements to a specific location. Instead of naively calculating the cost for each box, we can efficiently solve it using two passes over the array, one from the left side and one from the right side. So here's our approach. We are going to maintain four variables: the balls to the left, and moves to the left, balls to the right, and moves to the right. We want to use a single pass, so as we traverse this array from left to right, we will calculate and update the moves for the left side, simultaneously traversing from the right to the left, updating moves for the right side. And then we can combine them once we meet. So, how do we implement this? Pretty simple. First thing we're going to do is identify n as the length of our boxes array. Then identifying a new array called answer, which is going to contain our answer array, and it's going to be of length n because our boxes is also of length n. So now we're going to identify the variables that track the left side. So we're called left balls is equal to 0, and left moves is equal to 0. And then we'll do the same thing for the right. So right balls is equal to 0, and right moves is equal to 0. Now we'll take a single pass and calculate the moves from both the left and the right side. So for I in range n, as we want to do a single simple pass, so I will go from 0 to range n, we will update our result for the current box with left moves. So answer of I will be plus equal our left moves. We'll get into how this works in a second. Our left balls will plus equal the int value of boxes of I. So if I is currently, or boxes of I is currently 1, we will add how many balls are there. We'll update the left moves for the next box as well. So left moves will plus equal our left balls. So how does this work? We are going to keep track of, sorry, I can't see my mouse for some reason. So we're going to keep track of the left moves by calculating how many balls are at a specific index. So if there are 5 balls at an index, it's going to take 5 moves to move all those balls over to the next index, getting those balls to the next index of I, so I plus 1. And that's how we're going to calculate this, and we'll do the same thing for the right side. So to calculate our right side, it's the same thing mirrored, except we have to identify a variable j as j is equal to n minus 1 minus I. So this is going to be on the complete opposite side of the array, and this one's going to go negative. So as n increases and I increases, it'll decrease in return. So we need to update the same results. So answer of j is going to be plus equal our right moves. Our right balls will plus equal the integer of whatever is in boxes. So integer of boxes of j, and then our right moves can update adding our right balls. So we keep track of how many total balls we need to move. And that's it for this problem. Now we can return our answer. So if we run this, passes our test cases, and if we submit it, passes all solutions. And this problem is a time complexity of O(n) because we simply do one pass through the string, and a space complexity of O(n) due to our answer of the array and prefix sum calculated. So that's it. Thank you, and follow for more daily LeetCode solutions.